Hello everyone. In this video I quickly wanted to go over warm-up 2, just more so explaining the solutions for these 10 problems. For number 41, we have an answer of 5 and 1/4. This is just a matter of reading off of a ruler, looking at the tick marks there, seeing that that's 2/8. It does say express your answer as a mixed number. This is a common theme we're going to see in these questions, the type of response that you give. Since it's saying mixed number here, I want to be careful to answer exactly like I have it written 5 and 1/4. We'll see some other variations where they might ask for a decimal, and we'll also try to briefly explain what it means when it says common fraction. For number 42, this was the 57 minutes at a pace of 10 minutes per mile. So this is just a matter of dividing. Two kind of simple ones to start off here, 5.7 miles for number 42. For number 43, this was buying the candy. How much change should they get back? You don't have a calculator, so just kind of tedious multiplication here. It adds up to $1.97. It said the person paid with the $5 bill. Therefore, you would get $3.03 back in change. For number 44, we were told what number is 1/3 of the way from 1/12 to 5/12. So what I did, I found the difference between 5/12 and 1/12. That's 4/12, or 1/3. I broke that up into 3 equal pieces. That will be 1/9. And then I found out how far away is 1/9 from 1/12. Therefore, adding it to 1/12. Getting common denominators of 36, you'll get 7 over 36. Okay, common fraction, what that's going to imply is, in this case, we didn't really have any other choices, but simplified as much as possible, and also improper if possible. So if you had like a mixed number, like going back to number 1, giving it as a mixed number actually would have been wrong if it said express it as a common fraction. So common fraction is as simplified as you can, also improper if you can. For 45, what is the sum of all the one-digit numbers, one-digit prime numbers? Be careful, don't count 1 as a prime number. 2, 3, 5, 7. That's just 17. Kind of simple. For 46, this is a good one. My diagram is probably not super clear. This is just how I did it as I was reading the problem. So let me use my laser here. So I started right here. It said he went 3 miles west. This is obviously not drawn to scale either. I'm not like using the, well, kind of, I guess. I wasn't really using the boxes or the grid. 3 miles west, 2 miles north, 3 miles west, 8 miles south, 2 miles west, and then I drew this line because it said how far is like the end point to the original in a straight line. So in red, what you see we can make there, obviously the trouble with this is we had straight, directions. We're trying to find a diagonal. So my strategy was to make a right triangle. It works out very nicely to a common Pythagorean triple, a relative of the 3, 4, 5. That is the 6, 8, 10. If you're not familiar with that, if you're not recognizing 6 and 8 when you see it, you can use Pythagorean theorem. 8 squared, 64, plus 6 squared, 36, is 100. Square root of 100 is 10. Now that's not the answer, unfortunately. It says how far in total, so good kind of trick where people will just answer 10 because that was the hard part of the question. You have to then go back and add up all the other distances to get an answer of 28. For 47, a cube has a side length of 8. A prism is found by doubling the length, halving the width, and tripling the height. So doubling one dimension, but then cutting the other in half is going to have cancel each other out. Let's say you're times 2, but then dividing by 2, right? Or times a half and times 2. So those two actions are going to cancel one another out. So tripling the height is going to have the impact here. The answer is just 3 times. Okay, I can write it out like this. The volume of the cube would be 8 cubed. The volume of the prism, you certainly didn't have to go through this, but just kind of showing you. The volume of the prism would be 8 cubed times 3. So how much larger? I don't even need to know what they actually are. You can clearly see now that the prism is going to be 3 times larger. How I derive the 8 cubed out of this, if you're curious too, I could think of 16 as like 8 times 2. Then we have another 2 times 4. That's another 8. There's an 8 hiding in the 24. So you can find 8 cubed within here. and just a 3 as a remainder. 48, we have some equation stuff, right? 48, you end up getting C equals 6 once you plug in, kind of like a system, I guess, where they're giving you a lot of information. 49, 49, obviously, we don't have a calculator. You're not going to sit there and add it all up. So what I did was we figured out that there were 20 789s. So I said 789 times 10 times 2 to kind of make it a little bit easier on myself. You could certainly sit there and just do times 20. Times 10 is just a matter of adding a 0. And now times 2, what I did is a little trick here to show you, sometimes maybe to save a few seconds. I considered 8,000 times 2. That's a lot easier. And then the difference between 8,000 and 7,890 is 110. That times 2 is going to be 220. So like I was 220 large, so I took 16,000 minus 220. Just a quick little trick. That might be counterintuitive and end up costing you more time if you don't understand that. So you could have sat down at the very beginning of this problem and just done 789 times 20. Just trying to show you some kind of hack ways of doing questions like these without a calculator. And the last one, a little bit of a trick question, I suppose. We're told basically we have this, is it a cube? Yeah, we have a cube and we're removing a cube from the corner and it's saying what is the surface area of the figure. So it kind of looks like a scary question, like, oh, surface area is kind of annoying. We have this weird shape. I'm gonna have all these different faces I have to consider. But when you start to actually, luckily they were nice enough to give you a picture here. When you look at it, what you'll realize is removing that cube doesn't actually do anything. It has the exact same surface area as if the cube was there. The best way to think about this is look at the faces that are there once the cube has been taken away. They're in a different place, yes, but they're all still there. Nothing has been altered, nothing has been changed. You still have a face that you can kind of fill in the blank with what's been altered when you did remove that cube. Difficult to explain, I know, and I'm probably not doing a great job at it, but basically the surface area is unchanged, so you could just find the surface area. The formula for surface area of a cube is 6 times side squared. Basically, there's 6 faces on a cube. Finding the area of one of those squares times 6. So that would be 10 squared. 100 times 6 would be 600. Again, removing that cube doesn't change anything. If you're not sure what I'm talking about, look at the picture a little bit more closely now, and you can see what I'm talking about. You can kind of slide a face over a little bit and you're like, oh yeah, that side is still there. It's just off, a little bit behind it. All right, this was warm up 2. These 10 solutions. I know I was absent today. I apologize. Hopefully this will serve as a little bit of work or practice you guys can get in. I don't want to leave us hanging for 2 weeks. I'll probably post another weekly task. We'll look at last week's weekly task. Next Tuesday, we will be meeting next Tuesday again, 2:30 to 4 o'clock. See you guys there. Have a great day.